is a video on VBA functions, both built-in functions and Polaris provided functions. It's part of a continuing series of videos on Excel and VBA best practices, which focus on manipulating and accessing external data. This video is brought to you by PolarisInvesting.com, a site for creating defensible valuations. As a reminder, business valuation is based on expectations derived from skillful consideration of past facts and future possibilities. As we discussed in the very first video of this series, which was the introduction, the videos are broken up into a group of videos that are more about the user-facing part of Excel, and then another set of videos, which this video includes, is more about the back end, behind the scenes VBA. Well, the first thing we want to talk about in this video is using Excel built-in functions in VBA. To do that, I would like to go back through a spreadsheet that we used in the Excel functions video, where we talked about specific built-in functions. Reminder, we had there's a cell here where we can select what string we're looking for in this text. John sells apples. So when we're looking for the word apple in this, both the search and the find locate that 12 characters into the text. If we change this to something like orange, you notice here that both search and find return essentially errors. So we'll see when we run these Excel built-in functions and get something like this back. It's essentially like Excel threw a runtime error during the execution of the function. So when we run the built-in functions in Excel, we precede the function name with either application dot or worksheet function dot. Now, like I just said, in the worksheet, if there's an error, it's essentially a runtime error as the function is being executed. So therefore, when we use worksheet function in the VBA code, you're wanting behavior around errors, just like it is done in Excel. And in that behavior it creates a runtime error. Now, another way to invoke the function is to precede the function name in the VBA code with application dot. And the distinction there is now assuming that the application, the VBA code, will have an opportunity to handle the error in line in the code with something like WorksheetFunction.ifError. Or ifError is also an Excel built-in function, so you have to precede it with the worksheet function. But when you use the word application before the function call, you're essentially saying the VBA code is potentially going to handle it right in line. Now, if it doesn't handle it in line with some kind of an if statement, it'll just end up in throwing a runtime error. Another thing you should know is the worksheet function. This phrase here is a property of application in VBA. So it's equivalent to, sometimes you'll see it referenced as application.worksheet function. But you can either use that or just worksheet function by itself, and it's assumed that it's preceded by application dot. Well, let's look at actual VBA code of invoking built-in Excel functions and properly handling the error. So we're going to look at this function called JSON parser. We're actually going to be talking about this function again in a later video. For this discussion, I want to focus this on the error handling part. You can see here that all VBA code, you can specify what to do on a runtime error. On error, and here it's saying go to a particular label, and it just has it here, go to this location error handler, and then it just says we're going to set the value of the function to just not found, and the not found value is actually passed in when the function is called. Now I want to focus on this line here that has specific handling of errors. So you can first of all see that in order to call a built-in Excel function called ifError, we just use the worksheet function. So that means that if there was a problem with the ifError function call, it would just be a runtime error, and we would just return down here the not found value. But assuming that there's not going to be a problem with the if error, then inside the if error, we run the command application.find. Now, application, if you recall, means that it does not immediately create a runtime error. And so it gives a chance for the if error function to handle it in line. So if you run this and it doesn't find, find will return a runtime error in Excel. So we run it and say we want to handle the error in line. So if we do have an error, the if error will result in this being executed. And then when we run this part here, we don't use application find, we now use WorksheetFunction find, because now we're looking for a different character. We're saying, okay, if you don't find a comma, do you find a right bracket? If you don't find a right bracket, then just generate a runtime error and we'll return value, the not found value. I want to also point out that did choose to use find in this function as opposed to calling Excel's built-in search function. And the main reason is that find is case sensitive, whereas search is insensitive. It doesn't matter for the kind of characters that are being searched for here. But again, I want to point out that there is a difference between a find and a search. Next, going to talk about built-in VBA functions that are often used in manipulating and accessing external data. First one here is the Instr function, very similar to the search and find functions in Excel. The one is replace. Replace has got the same name as the the function in Excel, but it has a different parameter list. So just to compare those two functions, Instr and replace, with their comparable functions in Excel. Let's look at here that in the Instr has a start position, string, and substring. And it accepts wildcards and it's case sensitive. Big difference between Instr and the comparable Excel functions search and find is if you look for a text that is not found, search and find will return errors, whereas the VBA Instr function returns the number 0. So sometimes that's important. In fact, we saw that in the JSON parser function. The replace function has more of a traditional, or what you would expect in terms of input parameters. That you specify the string you want to search, text that you're looking for, the new text you want to replace it with, where you want to start the search, and then the number of times or instances you're looking to replace. If that isn't provided, all instances are replaced, and if start position isn't provided, it starts from the beginning. Replace function is case sensitive. Compare that with the Excel replace function, which specifies a string, but then it's starting character or starting position, number of characters, and then replacement string. So that Excel function is more of just move to a particular position in the string, remove a certain number of characters, and then insert some other text. Since we are talking about string functions, I want to mention the like operator, which returns true or false. You enter a string, the keyword like, and then some pattern. You see here the different wildcard characters you can use in the pattern. Here's an example of using it in some code where you have a string of the keyword like followed by the pattern that includes some wildcard characters that returns a true or false used in an if statement. Note, like operator is case sensitive. In fact, VBA comparison operators replace Instr and like are all case sensitive when the string comparison method is default option compare binary. All right, some other functions we want to talk about here are IsNumeric. In Excel, that's called IsNumber, but it performs as the same thing. You have uppercase, lowercase. You had that in Excel, but it was just referred to as upper and lower. We have format in VBA, which is similar to the Excel text function, at least in terms of what its function is, formatting data. Msgbox we'll revisit here shortly, and InputBox. You have the ability to call the Excel Transpose function, and you often need to in VBA. And we'll be talking more about some of the shortfalls of the Excel Transpose function using it in VBA code, and we'll talk about that in subsequent videos. Other thing I want to point out is that if you want to get row number of the last non-blank cell in a column, this is an explicit way to do that in VBA. Another way to get last row is to append .CurrentRegion.Rows.Count to a range. Let's back up here and talk about the use of Msgbox and Mbox in VBA code. So what we're showing here is an example of calling a Msgbox function. You just enter the text that you want displayed. Advisable that you always use the additional parameter to indicate what kind of input you're expecting, and then add a title for the box, so when it comes up it's clearly labeled as to what the box is about. In this case here we're saying the only input expected is the OK. Let's take a quick look at that here in the QueryIt spreadsheet. And you can see here a pop-up comes up, the title, query, and then the text that you're having displayed, and the only kind of input you're really looking for is just the user to acknowledge with OK, and then it goes ahead and runs the rest. Now we go look at that underlying code. You can see here that this is what caused that message to come up. So here's the text we're displaying, and then OK only, and then the word query at the top of the message box. Now this is when you say VBOK, you also could just use the number 1, and then you can see here 2 is cancel, 3 is abort, 4 is retry, 5 is ignore, 6 is yes, 7 is no, and we'll see that come into play when talk about the input box. But if you require a yes, no, or cancel response, you would need to set the message box equal to a variable. In this case, the variable is just called yes, no, and then it would contain a number. You can see here if the number is 6, which would mean the user replied with a yes, or you could also be looking for no or cancel. Okay, you can look for any input, but typically you look for when you're setting up for yes, no, you're looking for the yes and take some action. When you're expecting text to be typed in by the end user, you use the input box, and then whatever they type in, you set it into some variable. In this case, setting it to the input value. And there is no, like with this normal message block indicating what kind of input you're expecting. You just specify the title of the box. Now, it's important that once the input box function is called, that you look for VBA allocating memory for your input value. If it's 0, then it means there was no input provided. Now you could have the follow condition that if there is input, you want to make sure the input wasn't blank. And then you have an additional check that if you're expecting a numeric, you'll check to see if it's numeric. A related topic to Msgbox is Application.StatusBar. Application.StatusBar is displayed in the left portion of the Excel status bar. It is useful to display information to a user without requiring a response from them. It is often used to display progress information, as shown here in this system check subroutine. There is a known issue with Application.Status when used in a called subroutine where the previous message displayed from the caller is intermittently displayed. Excel is a multi-threaded application that makes extensive use of background processing. This background processing is suspected to be the cause of the problem. To minimize the impact, it is suggested to use do events immediately before using Application.Status. Also, a best practice is to not use Application.Status in called low-level subroutines or functions. Rather, have a high-level subroutine like system check that makes all the calls to Application.Status. Even though not functions, I want to briefly mention some common conditional statements. First off is an inline if statement shown here. Second is a single statement syntax of an if statement. And then there's another syntax called multiple statement syntax of an if statement. We also have an else if syntax. Another kind of conditional statement is the select case statement. Most straightforward example of it is that you have some variable and then you can have different values of that variable. A creative use of the select case is to use a condition of just true, and then it'll continue to evaluate each case clause until the condition is true. You can use this instead of else if. All right, next year we're going to talk about Polaris provided functions that you'll find useful in your VBA code. Some of these functions we've already talked about when we were talking about useful Polaris functions up here for Excel, but you can access them here in VBA as well. So we're going to briefly mention some. We'll also mention some that haven't been discussed before. So we're just going to go out there and look at Module 1 and Module 2 in the QueryIt spreadsheet. So update time, as we talked about in the Excel video, it's best not to use the volatile now function in your code. It's best to just, when you want to get the current time, to call update time, and update time will not be recalculated every time there's a calculation. It'll only give you the updated time when you explicitly call it again. Column number we already talked about. You pass in the column letter, returns the column name. So an example would be you call it with the column letter of C, it'll return the number 3. The opposite of that is column letter. You return it, you enter number 3 and it'll return C. The next one here is TransposeArray. There is an Excel Transpose. We briefly talked about it a couple of minutes ago. About you can call it Application.Transpose, but it's got a serious limitation in dealing with blanks. This Polaris supplies TransposeArray, and we use in the, you'll see it being used later on when we talk about accessing external data in more detail. It does accommodate blanks so that it doesn't error out unexpectedly. Next function is not specific to manipulating or accessing external data, but just be aware that it does exist. It has to do with internal rate of return. X stands for extended internal rate of return, which Excel does provide, but this one is built so it handles short sales, and I'm not going to get into detail what that is. It's just suffice to say that this is a little more robust version of the Excel provided extended internal rate of return function. Okay, the next one of interest is random. Now there is a built-in function that's called rand, but if you just call it without calling randomize first, which is another VBA function call, every time you start up Excel and run the same code, you'll get the exact same random numbers. So really, that without using randomize really exposes the rand function for what it is, and that namely it's pseudo-random. So what you want to do is you want to call randomize, and what that does is gets the current system time on the computer, seeds the random number generator with that. Then when you call ran, it's going to be truly random. And this next function, maximum of array value, this MaxArr, you just pass in an array and it'll return the maximum value it found in that array. Next one is min array, so minimum of values in array. Mean, this returns the mean of the values in array. Standard deviation, S means sample, but pass an array and it gives you the standard deviation. Next function that if you're charting things, it helps you scale your chart. You specify whether you're dealing with the X or Y coordinate, and you can see here if it's Y, or you use one thing, but if it's X, you use something else. Then you specify the minimum max for the values for that dimension of your chart. Next one, we've already talked about these in the Excel videos. Is connected, public IP, computer name, Excel version, username, latest version, spreadsheet open. So let's we talked about this already as well, but let's go through it again. The last row in a column. This is just if you want to be really clear. And I already mentioned you can use a .CurrentRegion.Rows.Count appended to the end of a VBA statement like range. The last row in column function is just a more explicit way to determine the last row. DistinctSort, we talked about that in the Excel videos, but here's the actual code for that. And then it's also makes use of this selection sort. Since this video was originally recorded, there's some additional Polaris provided functions that I want to quickly go over. One is IfBlank. You simply pass in a value and also a replacement value if it's blank. So when this function is called IfBlank, if the value passed in is blank, then the replacement value is returned. If the value is not blank, then that original value is returned. If for some reason you want to return a blank, just put as a replacement value blank, double quotes. Several of these other commands deal with worksheets. One is called the WorksheetNameExists. You pass in the sheet name and it'll just tell you if that name exists in the spreadsheet currently. WorksheetIndexExists. You pass in an index and it'll tell you whether that exists or not. Tab number. You pass in the sheet name and it'll return the tab number from left to right. Excel numbers worksheets 1 through N going from left to right. Tab name, if you know the tab number from left to right, it'll return the text name of that tab. Now, probably should have used tab instead of worksheet for these first two functions. Just make sure you know that whether it's tab or worksheet, it's referring to a worksheet. This command here, active tab name, you simply call it with no input parameters and it'll tell you what the name, text string name is of the current active worksheet or tab. And this last new command that Polaris is providing is called indirect trigger, and it's very useful to avoid automatic recalculation of the indirect function. So it's just like the indirect native Excel function, except for there's a trigger provided as a second parameter, and it's just simply a cell or range or several ranges embedded in a choose command. If any of those values change, then this function, when it's called, will be recalculated and then the string reevaluated. But the big benefit of this Polaris provided function over the native Excel indirect function is that you can control when it's recalculated. It's not automatically recalculated on every calculation. Okay, now switching over to module 2 of this QueryIt spreadsheet. Talk about two functions that are used quite a bit when dealing with external data. So I want to spend a little time on it. We will spend more time on both these functions in subsequent videos. But the first one has to do with comma separated values, and it makes use of a VBA built-in function called split, which is a very powerful function. But what you do is you pass in a string and then a delimiter that you want it to split out your string, and then you'll end up with array element for every delimiter that it found. In this case, function, what we're doing is we're using the carriage return, which is char 10. So we're just saying, give us all the distinct rows, and then you put it into an array. Now this array is offset from 0 to n-1, but I want to be clear that the function, you pass in 1 to n. So the way the function works is you say, hey, I've got the string, I'd like the let's say third row in the fifth column in that row. But the code itself, this actually ends up being from 0 to n-1. So that's why you see a subtraction 1 here in the code. But the first step is to use the split function and split out based on carriage return to get your rows. Okay, then what it does is it calls the split again, but what it passes in as the string is the row, just the one row that that's been asked for through the input parameter when this function is called. And then what it returns back is a array full of columns, and then based on the column you want, it looks up the particular cell of the array, and then that's what gets passed back. Like going over this use of the split function, did want to back up and talk about a different way here in VBA that you can determine the number of occurrences of a string there is in a particular text. What we're showing here is what we did back in the Excel function videos. We just took the length of the string minus substituting the substring that we're looking for with blank, and therefore you end up with a string shorter by the number of instances of that substring that you find. So when you subtract it off from the original length of the string, you get how many occurrences of that string you had in the text. Well, another way you can do that in VBA is you can use the split function. Split out from the text. Every time you see an occurrence of the string that you're looking for, you break out into a separate element of an array, and then you just do the upper bound of the first dimension of the array, and that gives you a number of occurrences. All right, the next function in this module too that talk about is the JSON parser. Now we have talked about this in the previous videos, and we'll be talking about it more in future videos, so I'm not going to spend a lot of time on it now. But what it takes as input is a JSON formatted string, and then you specify the name and the instance of that field that you want returned. And if it's not able to find that field name or that instance of the field name, you also specify what you want returned if the value is not found. Now, we went through this in pretty much detail when we were talking about error handling, so I won't go through that part of it again. And we've also talked about the use of this substitution command, and kind of tricky way to find a particular instance of something in a string. But you end up finding the start position based on using the substitute command for that instance, in position based on the delimiter that you're looking for, either a comma or a right bracket, and then it returns the value that it found. I want to make sure it's understood that this JSON parser is not a universal parser for JSON, but it works for most cases. Where it doesn't always work is, here's an example of JSON formatted data. We will be going over more in later videos, but I just want to make sure you understand the issue here. Is that it works fine for something like what's shown, but let's say that down here under phone numbers, this number right here, for some reason, was titled first name. So now you've got an object that consists of all these fields, but it's also got a sub-object under it with a field name of the same name as a field in the parent object. And then that'll just throw off the instance count. Next thing I want to mention in this video is, again, watch out. VBA does have round, but it has the same limitation as the Excel round that we talked about earlier, that the way numbers are stored in a computer in a binary form, that the round of a plus b does not equal the round of a plus the round of b in all cases. Another common problem created by a computer storing decimal numbers in binary is in looping. This is best demonstrated with a quick demo here in Excel. You go into the developer and just write a real quick little program here. Basically what it does is it just enters a very tight loop. Now the way it's looping is it's starting off with some divisor that I enter into a cell, which I'll enter in over here in A2, and it'll then loop through. So the first time through I'm going to enter a divisor of just 1, so it'll go from 5 to 100 by 5, and it will expect the number to come back as 20. So let's try that. I'm going to go over here and enter in a divisor of 1, and you can see it gets back a result of 20 as it counts the number of times that it went through the loop. If I up the divisor to 10, I also get 20. I up it to 100, I get 19. So if we go back and look at the code, what happened here is when I took it all the way up to the divisor to 100, 5 divided by 100 is 0.05. So we went from 0.05 to 1, stepping it each time by 0.05. So you expect the result to be 20. Now to understand what's happening, you need to go look at the details on how the for loop actually works. And if you scroll down here, you can see here that it says it stays in the loop as long as the counter, if you're talking about a positive stepping, as long as the counter is less than or equal to the end value. So what we have here when it gets up to 100 is we have 0.05 going to 1, and we're stepping by 0.05. So let's start off with 0.05. Next time through it's 0.05 plus 0.05, it's 0.1. Then it goes to 0.15, 0.20, and then eventually we expect it to, on the 20th loop, to equal exactly 1. Well, the problem is that this division here, when you take 5 divided by 100, you're not getting, the way it stores it in binary, it's not exactly 0.05. In this case, it's a little bit larger than 0.05. And the same true with the stepping. It's just also slightly larger than 0.05. So as you add this slightly 0.050001 number to where you started off, by the time you loop around the 20th time, this condition of less than or equal, well, it's actually on the 20th loop, it's just slightly larger than 1. So it drops out of the loop and you get 19. Now there's two common workarounds for this. One is to come up here and just add to the final value you're comparing to something like 1 divided by this divisor. And that'll make the final number you're checking against not be 20, but slightly larger than 20. So now if we come over here and retype in 100, you see we get 20. Now that works, but probably a better way to do it would be to drop doing anything decimal or fractional in the loop counters themselves and make them all integers. So what we do is you would drop the use of the divisor here, and let's say if this is where you wanted to go 5 to 100, and then forget about adding this little extra piece here, and then we just step it by 5, and so now we're dealing with it just integers, and that's going to work fine. Then inside the loop you would have some result that would be calculated that would be equal to the value that you're looping through divided by 100. So you're dividing inside the I value as you loop around. So you don't do it here, you do it as your first step inside the loop. This has been a video dealing with useful functions in your VBA code. Thanks for watching.